So hi everyone, how you guys doing? All right. So sorry, due to slight technical issue, I had to, but session got slightly delayed. But anyways, now we are here. So first of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, which is India's largest online learning platform for IIT JEE. And on this particular channel of YouTube, every concept of physics, chemistry, and maths are being taught to you completely in English. Now, hello Motilal, how are you? Hi, Amod Kumar. So, on this is a series that I host for class 12 students. The topic that we are discussing right now is waves. This is quick review part 4 of waves. Now, before I get started with today's discussion, let me introduce myself for those of you who might not know me yet. So, my name is Rohit Dixit, and I study mechanical engineering from IIT Delhi. And for almost past 8 years now, I've been teaching physics for the IIT JEE exam, both mains and advanced. And most of that teaching had been in offline setups. Now, last year only I started this online venture. All right, so let's see how it goes. And now, as a student, I myself was All India Rank 447 and All India Rank 182 in the two stages of the IIT JEE exams that I took. So back when I took the exam, again, it used to happen in two stages, just like it happens in two stages right now for you guys. You go for mains, and if you qualify that, you go for advanced. Similarly, back when I took the exam, there were two stages again. So the first stage used to be called the IIT JEE screening, and the second stage was called IIT JEE Mains. Now, screening was an objective paper, and in that paper, I had secured an All India rank of 192, and in the subjective JEE Mains paper, I secured an All India rank of 447. Now, I also qualified the NTC Stage 2 examination as a student, and I was in the top 1% in the NSCP exam as well. Now, in all my offline years of coaching, I've coached many students to top ranks in the IIT exams, both mains and advanced. And now I hope to continue guiding you guys here online. All right. So any student who is worried about how they can make sure that they are receiving quality education and their studies are going uninterrupted even in this era where most of the students hardly have any access to their educators and good education. So a great opportunity lies in front of you. So you guys can get yourselves the Unacademy subscription. Now, this subscription will give you benefits like live classes, where you get to interact with your educators on a regular basis. Then you also have live polls and leaderboards in these classrooms, which keep them highly interactive and quite efficient. You also have test series and regular analysis sessions, which will again keep you on your toes, keep you aware of your standing in the competition, which is very important for a competitive exam like IIT JEE. And of course, you have live doubt clearing sessions. So for all Unacademy Plus courses, every fourth session is supposed to be a live doubt clearing session. So after every three teaching sessions, you have one session which is dedicated entirely towards your doubt solving, so that your doubts never pile up with your Unacademy Plus courses. Okay, so apart from all these benefits, you of course get another chance, another great opportunity, which is the chance to study from the topmost educators from all across the country from the comfort and safety of your home. So you're getting the best education from your home itself. So that's a wonderful opportunity, and every student I think must look to you capitalize on that. Now, so how do you avail all these wonderful benefits? So the first step towards getting started with your IIT JEE journey requires you to install the Unacademy app. So once you do that, you will unlock for yourself a lot of free features offered by Unacademy, like free courses. So all on the Unacademy Plus app, you have free courses which any student can register just if he has installed the Unacademy app. Plus, you can also attend special classes. Okay, these are again free to attend for anybody who has just installed the app. And finally, you can take part in quizzes like the one we keep hosting every now and then. Okay, so these free features are available to you without any subscription. All you need to do is install the Unacademy app for that and activate all these free features using the code RD Live. Okay, so that is all it takes to for you to use these free features. So this will already get your IIT studies started, and once you realize that how your studies are going to go with the Plus subscription, and once you want once you are ready to take your JEE preparation to the next level, then this is what you can do. Finally, to get the Plus subscription, you can go to the Plus section of your app. Select your goal as IIT JEE and click on that Get Subscription button. Next, when you do that, you are redirected towards the payment page, wherein you will find a box which will say, do you have a code? So that is where you can enter this code, RD Live. So this code will give you a 10% off on all your subscription fees. Okay, now whether you choose the Plus subscription or the Icon subscription, you will get a 10% off on both your subscriptions. Now, these are the fees of the two subscriptions as mentioned here. And you will also realize once you click on proceed to pay, you also get an option to break these payments into a lot of no cost EMIs. So you can break this one payment into a lot of smaller payment options, which will definitely help you reduce the burden of this payment also. Those of you who don't know what the iconic subscription is, so let me tell you a bit about that. The iconic subscription is something that will take your IIT JEE preparation to the next level. So how does that happen? So from our team of experts, you are allotted personal coaches. These personal coaches will closely monitor your performance and mentor you throughout your IIT JEE journey. So you will be getting a lot of individual attention from these personal coaches. And apart from your other plus benefits, you will get to attend extra IIT JEE workshops, receive expert guidelines from time to time, get a study planner, and get regular test analysis sessions. So your personal coaches, your plus benefits, and these extra benefits will make sure that you power through your IIT JEE journey. Now, students who have just entered class 11 and are worried about how they can go about their preparations. Now you don't need to worry because Unacademy offers you combo subscriptions now. So these combo subscriptions take care of all your study needs for the next 2 years. So whether it is your class 11th studies for schools CBSE, whether it is your class 12 CBSE studies, your board preparation, whether it is your IIT JEE Mains preparation, or whether it is IIT JEE Advanced preparation, all your study worries taken care by these combo subscriptions. So there are four combos that are offered by the Unacademy right now. So in the first combo, you get the iconic subscription for IIT JEE and you get the plus subscription for CBSE 11th and 12th. And this combo starts at around 4,600 a month. In the second combo, you get the plus subscription, the iconic subscription for all three. This combo starts at 5,500 a month. Finally, you have a combo where you get plus subscriptions for all three. This combo starts at 3,000 a month. And then you have another combo where you get the plus subscription for ITJ and Iconic for 11th and 12th. And this combo starts at 3,900 a month. Okay, so again, you can choose any combo that suits your preparation needs. And then you don't have to worry about anything for the next 2 years. All your needs of your preparation would be taken care of with these subscriptions. This is a list of upcoming tests in January, so please do not forget to take part in the Unacademy Combat, which is going to happen tomorrow live. You can enroll now using the code RD Live. And if you do well in this, then you can win yourself some really cool prizes. Then you have AIM Advance 2021 series going on, which happens every Saturday. And of course, you have unique DPP discussions happening every Monday through Thursday. So you can take part in all these and benefit from all these features being offered to you. Now, those of you who are following us on the JEE English channel of YouTube, do not forget to connect with us on the Telegram app using this link. So that will make sure that you're receiving all the timely notifications of every session and lecture happening here on the JEE English channel, and you're not missing out on any of the amazing content provided. Sine kx cos of omega t. This would be a typical equation of a standing wave, which you see here, and you will see alternating nodes and antinodes. Okay. Next, we were discussing the applications, the practical applications, the lab methods of finding out the frequency of an unknown tuning fork. So this is called the sonometer wire setup. So let's see. Again, IIT JEE has asked a lot of questions from here, and this is one lab method. So you might have also tried it in your labs. I don't know if nowadays you guys go for any practicals, but I definitely did do this. So hi Rajesh, hello Aftab, hi Mahi, how are you guys doing? I definitely did perform this experiment as a student myself. So what happens is that you have a string, okay, so which is again you don't actually have this. Okay, so you have a string, okay, wherein you have a weight which is attached with the string. So this weight can be adjusted. Now this weight can be adjusted according to you. Now that will adjust the tension in the string. Then you have two bridges. Okay, you have two bridges again. So you have bridge number one, and you have another bridge kind of a thing here. So you can adjust the distance between the two bridges. And what you do is you have a piece of paper here, which you keep on the string, and then you bring a tuning fork and you keep it above that. So the tuning fork induces force vibrations in the string, and you keep on adjusting the distance between the two bridges, and hence changing the length of the wire in which you're setting up standing waves. What happens is for these waves that you're setting up, again, these bridges help you create a bounded medium. So this is a bounded medium in which you are setting up the waves. So whenever the external frequency of the tuning fork matches the natural frequency of the wire, then you see a resonance happening, and when resonance happens, then this piece of paper is seen to fly off. Okay. So the basic principle behind this experiment involves resonance set up in the string by the tuning fork, the unknown tuning fork. Okay. So what you do is you keep the bridges almost touching each other, and then you start increasing the distance. And at certain length L, the resonance happens, and the piece of paper flies off. So I will say that the piece of paper fly off when the distance between the bridges is L. Now, what I can say is at this moment, the fundamental frequency of the string must be equal to the frequency of the tuning fork. Okay, at this moment, fundamental frequency of the string will be equal to the frequency of the tuning fork. Okay, so if I can calculate the fundamental frequency of our string, then we can figure out the frequency of the unknown tuning fork. Okay, so that's the basic principle. That's the basic idea. Okay, so let's see how that happens. Now I know that sorry, we can measure the length sorry of the resonating string L. Okay, Now also in the string equals mg, where m is the external weight that I'm hanging. Okay. Now mu of the string is also known. Okay, so you take a string for which you do know the mass per unit length. Okay, so therefore, C would be equal to root E over mu, and mu of tuning fork would be equal to C over 2L. Okay, so this is how you can finally figure out the frequency of the tuning fork. Okay, so this is a method. Now you could have changed it also. So this is the first frequency, or if you keep increasing the distance, if the distance is increased further, if the distance is increased further, and resonance is seen at a length L2, is seen again at length L2, so let's call this L1. Then nu of tuning fork will also be C over 2 L2, 2C over L2, or C over L2, and so on and so on. So you could have keep on kept on adjusting the lengths. You could have also taken one length and the next length at which the resonance is happening, and found out the difference of them also, and that is also how you could have figured the frequency of the tuning fork. And so this is essentially a method how you find the frequency of an unknown tuning fork. Okay, by setting up standing waves in a string and trying to make the resonant frequencies of the natural frequencies of the string match with the frequency of the tuning fork. Okay. Now a similar experiment is also done with resonance column. So you can also find the frequency of a tuning fork with the help of a resonance column. So what you do in a resonance column is the setup is looks something like this. Okay, so what we do is we first fill a tube with water up to the brim. Okay, so first this tube is filled with water up to the brim, and then you can move this setup, which will reduce the level of water, and you set up a tuning fork here. Okay, so you have tuning fork setting up vibrations here. You keep the tuning fork here, and at some length, suddenly you hear a loud noise. That will be when the frequency of the tuning fork starts to resonate with the frequency of the resonance column. Okay, so there you can measure this L1, and similarly, if you keep on decreasing the level, again you will hear a loud sound at some level L2. Okay, so with the help of L1 and L2, now you can figure out the frequency of the unknown tuning fork. Okay, let the end correction in the tube, end correction of the tube be E. Therefore, what I can say is that I know for nu of tuning fork would be equal to C over 4 L1 plus E, which would also be equal to 3C over 4 L2 plus E. Okay. So I have these two equations. From these two equations, I will solve for E and nu of tuning fork. Okay. So I have two equations and two unknowns. Solving the two equations, solving the two equations, we can find both and nu of tuning fork. Now, sometimes in questions, you will be given data of one length only. Then either you have to ignore the end correction or the end correction is mentioned. Also, if radius or diameter of the tube is given, radius or a diameter of tube is given, okay, then you will remember tube is given, end correction is zero point 0.6 times R or zero point 0.3 times D. So that was another way with which you could have calculated the E and then figured out the frequency of the unknown tuning fork with a single value of L. Or if even this is not mentioned and only single value of L is given, then we usually ignore the end correction. Okay. Why don't we solve some problems and then let's see how to actually solve problems from these topics. Okay. So here is a problem which says for a certain organ pipe, three successive resonant frequencies are observed at 425, 595, and 765 hertz respectively. Taking the speed of sound in air to be 340, explain whether the pipe is closed-ended or open at both the ends. Okay. Also determine the fundamental frequency and length of the pipe. Okay. So try this. Let's see if we can figure this out. Okay, please note that the language says three successive resonant frequencies are these. Okay, now with the help of the given data, try and find out different values. Okay, if you are given three successive resonant frequencies, then how would you figure out whether the pipe is open-ended or closed-ended, and how would you figure out the length and the frequency? Think about this. Think about this, and I'll try and answer. Okay, so you guys try this. Till then, I'll help myself with some water. All right. Okay. So think about this. Think about this. Take some time. Think about this. Then try and figure out. Okay. So has anyone figured it out yet? So let me know. Let me know. Okay, as Pandey says, open pipe. Okay. Okay. And what else can you say? All right. All right. Interesting. All right. So let's see. Let's see how you would have gone about solving this problem. So first of all, if you remember, if imagine if your pipe was open. So let's assume both the things. If pipe equals open, then frequencies would be some n minus 1 c by 2l n c by 2l and n plus 1 c by 2l. Okay. If pipe was closed, then what do you know about the frequencies? How are the frequencies? The frequencies are 2n minus 1 over 2lc. Okay. And you would have had 2n plus 1 over 2lc, and you would have had 2n plus 3 over 2lc. Correct? These would have been the successive frequencies. Successive frequencies would have appeared like this. Agreed? Okay. Okay. Now let's see. Let's see. So if I find the difference, if I try to find the difference, okay, then what do I get? So what you realize is delta, you know, between any two, what would that have been? So for the first case, that would have been c by 2l open pipe, and delta nu would have been equal to, again, if I subtract this, then c by l for closed pipe. Okay, all right. So these are the two options that I'm getting, right? So either the difference would be equal to the fundamental frequency or twice the fundamental frequency. Okay, agreed. Now, if you remember, the open pipe has all kinds of harmonics, and the closed pipe has only odd harmonics. Okay, I hope you remember that. So first, what I need to find is the ratio of the to all the lengths, all the frequencies. Also, if I find nu one is to nu two is to nu three, what will that be? That would have been n minus one is to n plus one for a closed pipe, so for an open pipe, and this should have looked like 2n minus 1 is to 2n plus 1 is to 2n plus 3 for a closed pipe, correct? So this is the information that I have. Once I can figure out which kind of pipe it is, then I know the fundamental frequency. If it is an open pipe, then the frequency difference between any first two would be equal to the fundamental frequency, and if it is a closed pipe, then the difference would be four times the fundamental frequency, right? Okay, so let's try and find the ratio. So let's try and find the ratio of the given frequencies. Now new one, new, and what were new two and new three? mu2 was 595 and 765. 595. mu3 was 765. First, let's try and find the ratios. Okay, so let's try and find the ratios. mu1 is to mu2 is to mu3. Let's see how does that appear. So if I had to find the ratios, so let's see. So 425, 425, that would be 17. So 5 is 5. Not getting the exact ratio here. Let's see. 425 is to 595 is to 765. So let's see if we divide them by 5. This is 85 is to 119 is to 153. So let's see which one can divide them further. What is the difference that you see? Yeah, I think 17. So what you're getting is 5 is to 7 is to 9 actually. When you find the ratios, you are getting 5 is to 7 is to 9. So 5 is to 7 is to 9. What kind of pipe would that be? That would be a closed pipe. Okay, not an open pipe. This kind of numbers I should have gotten for a closed pipe. Okay, so this represents a closed pipe, guys. Therefore, pipe is a closed pipe. Okay, you are getting odd harmonics only. Okay, you are getting different odd harmonics. Now, once you know that, therefore, this would be 5C by 4L would be equal to 425. So C by 4L would be 1/5 of this. Okay. So this will be 85 hertz. Okay, guys. Hmm. Again, remember from here. 4. You would have had odd harmonics or odd multiples of the fundamental frequency. So the fundamental frequency actually will become 85 hertz. It will be a closed pipe. And now, how about the length of the pipe? How about the length of the pipe? So here, of course, you can say that if the fundamental frequency is 85, okay. So can I say lambda fundamental would be equal to 340 per 85. Okay, so let's see how much that is. So you guys were off slightly with your answers. So that is 4. Okay, lambda is 4 meters. Now lambda is 4 meters. So you also know for fundamental frequency, it's lambda by 4 equals L. So L equals 1 meter. So these are your answers. Okay, guys. The length of the pipe is 1 meter. The fundamental frequency is 85 hertz, and your pipe is a closed pipe. Okay, let's write your answers. Closed, 85 hertz, and the length of the pipe is 1 meter. These are your answers. Okay. All right. No mind. No. Let's give another one a try. Okay. Here is another question for you. So this question says a pipe closed at one end is in resonance with a vibrating tuning fork where when the length of the air column is 25 centimeters. Next resonant frequency happens when the length of the air column is 77 centimeter. If the speed of sound in the air is 338, calculate the frequency of the tuning fork. So let's see if you can figure this out. So try and figure this out. So with the given data, you have to try and figure out the frequency of the tuning fork. As I told you, this is the resonance method. Okay, resonance column method of determining the frequency of an unknown tuning fork. Again, a lot of questions. If you check the previous year papers, a lot of questions in advanced and mains have been asked from this method. Okay, so you guys should be very clear about how to solve questions using this method. Okay, so AP has an answer. AP says it's 325 hertz. Okay, let's see. Let's see. So, what did I tell you? I told you that the tuning fork, you have a resonance. First resonance you see is at 25 centimeter, and the next resonance is seen as at 77 centimeter. Okay, so you know here again. I told you how to go about this. Okay, this is what you do. So for the first resonance, you will imagine that that nu of tuning fork would be equal to C over 4 L1 plus E, and the second would be 3 times C over 4 L2 plus E. Okay, so that is precisely what has been given here. So from the given data, what we can realize is that nu of tuning fork is equal to C over 4 times L1 plus E, which is also equal to 3C over L2 plus E4, correct? Okay. Okay. So now I've been told L1 is 25 and L2 is 77, correct? So therefore, what I can say is L1 plus E must be equal to L2 plus E by 3. Okay, so what I can say is therefore 25 plus 3E plus 77 into 25 plus E equals 77 plus E. So from here, what I realize is 2E equals 2 and E equals 1 centimeter. So your end correction I've already figured out. Once I figured out the end correction, now there is nothing. Now I know nu of tuning fork would be C, which was told to me as 338 38 over 4 into the length is now 25 plus 1, 26 centimeter. Okay. So let's calculate this. How much would that value be? Let's see whether I can this 2 and this 6. Okay. And then I think we can Remove this with 13. This is, I think, 13 square, right? Not wrong. This becomes 2. That is 13 into 100 over 4. 5 into 13. So yeah, that is 325. So yes, well done, people. 325 hertz is the correct answer. All right. Well done, well done. So this is how you would have gone about solving this problem. All right, let's try another problem. Again, please solve all these problems. Make sure you're comfortable in solving these problems because from waves, most of the questions are asked from this only. Okay, this is an important topic. Standing waves is a very important topic. Whenever you see questions from waves, you realize in waves they usually ask you questions from two topics only, mostly standing waves or Doppler's effect. Questions of beats are usually too easy. The questions of interference are usually asked in YDSE. So in waves, particularly as a topic, I think the most important two phenomena are the Doppler's effect and this standing waves. So make sure you're solving these questions and are comfortable with these. So here is the next question. It says AB is a cylinder of a length of 1 meter fitted with a thin flexible diaphragm C at the middle and the two other thin flexible diaphragms A and B at the ends. So why are we fixing thin flexible diaphragms? So that the ends behave like open ends. Okay, that's essentially what your drums are. Like drum has this thin vibrating diaphragm sheet. No, so that behaves as an open end. Okay, other devices also. Your tablas would be open at one end and closed at one end. Drums would be open at both ends. Okay, those are pipes open at both ends. Okay, all your musical instruments are essentially based on your standing waves. I told you in the earlier class that your guitars are essentially standing waves on a string tied at both ends. Okay, so anyhow, let's move forward with this question. And the question says, now the portions A, C, and B, C contain hydrogen and oxygen gases respectively. The diaphragms A and B are set into vibrations of the same frequency. What is the minimum frequency of these vibrations in which the diaphragm C is a node? And under the conditions of the experiment, the velocity of sound in hydrogen is 110, the velocity of sound in oxygen is 300. Okay, so these speeds, wave speeds in the two columns have been told, and you have been asked for what minimum frequency will there be a node formed at C? Okay, so try and figure this out. Let's see. So you have two pipes of zero point 0.5 meter each, essentially. Okay, that is what the situation is. So if you want a diagram of the situation, I can provide you with that also. So you have a pipe. Okay, so you have a diaphragm free to vibrate at end A and a diaphragm which is free to vibrate at B, and then you have another diaphragm at C. So A, B, and C, and this is zero point 0.5. This is also zero point 0.5 meter. Okay, so here you have hydrogen, here you have oxygen. Okay, the speeds of sound are also known 110, 1100 meter per second and 300 meter per second. Okay, now you've been asked for what minimum frequency. Okay, so these are vibrated with the same frequencies. Okay, so you are forcing vibrations of same frequencies here. So nu and nu. So obviously there will be standing waves forming in both the columns. For what minimum value of nu will there be a node at C? That is what has been asked of you. Okay, so that is the question. Try this. P1 here is 1100 per second. Here is both are open pipes, but they do have diaphragms. They can find a node there. Okay, so again, try this. Try this. Let's give you 2 minutes to solve this. Yeah, I've already described the question for the past 2 minutes. I think I'll wait for another 2 minutes for you to figure this out. And if you can figure this out, then well and good. Otherwise, I'll go ahead and solve this. Okay. Hmm. Try this. Try this. This is a good question that can easily be asked in advance. It's a good advanced level practice question. Okay, so try this. Try and figure this out. If you can't, then of course I will show you the solution. Go through the question and see if you can solve it on your own. Remember the things that we have talked about, okay, and don't worry. So imagine two standing waves. Okay, I'll give you a hint. Imagine two standing waves and in two columns independently. Okay, both having nodes at one end and antinodes at the other. Okay, so for sure, you've been told that the diaphragms A and B are set into vibrations. So at the locations of A and B, you will have antinodes, and you want a node at C. So think of it as two separate pipes having set into vibrations, having antinodes at one end and node at another. And the frequencies should be the same eventually. Okay, so that's the hint. Okay. Hmm. What should be the minimum frequency of these vibrations? So anybody? Okay, so 2 minutes are up. So should I go ahead and solve this then? Okay. So you guys know that if I talk about both of these sections, talk about the section AC. So let's talk about the section AC. So in section AC, you know that here has to be an antinode, and then somehow after something, you should have a node here. Okay, after some loops. Similarly, in the other half also, you would have a similar thing, right? So pay close attention to this. So this is A, this is B, and here also you have an antinode here, and you have a node here. Okay. So let's say the frequency. Let's say in here frequency is some 2m minus 1 by 4 c by l c1 by l, and here the frequency is 2n minus 1 2 over 4 l. Now l's I know for both are half a meter. Okay, so let's assume when these kind of frequencies are set up. So I have told you that when one pipe one end is open and one end is closed. So this is how the frequencies will look like. Correct? Let me know if there is any confusion about this. And also these two would be equal. Correct? So what I can say is that the pipe AB for AC be resonating to M on a harmonic and pipe BC be resonating to N minus 1 of harmonic. So I am assuming that. So therefore, what I realized, therefore, mu for part AB would be equal to 2m minus 1 T1 over L 4L. Okay, so and mu of BC AC, mu of BC would be 2m to n minus 1 over 4L C2. Correct. And these two have to be equal. What are scoring chapters in physics in JEE? I think all of them. I personally think all of them, Vinay, because when I would pick up physics as a student, I would aim for at least 90 to 95%, somewhere between 90 and 100%. So because all the topics are scoring, you can't score that much in physics. See, physics is one subject where you can be confident about scoring. In chemistry, there are so many things that you cannot be always sure that anything that is asked you will know. Okay, because maybe there is something that you could not study. Maybe there was some part which you did not follow, or would you would not remember. Similarly, in maths, again, you might have practiced a lot. You don't really know if you'll be able to solve any question that is thrown at you. That happens only in physics. Only in physics you can be confident with your preparation that you'll be able to solve any question thrown at you. Okay, so I think physics is one topic where you should look to maximize your score. Okay, equal to the new. So I had told you this side and this side both are being set up into vibrations of the same frequency. So what I will realize is therefore 2m minus 1 C1 would be equal to 2n minus 1 C2. Okay, so C1 was 1100. Therefore, what I realize is 2m minus 1 over 2n minus 1 would be equal to 3 over 11. Okay, so now what you realize is therefore okay, so here is the part that you need to figure it out. You've been told 2m minus 1 over 2n minus 1 is 3 is to 11. So you can have or you can have 6 over 22, or you can have even written this as 9 over 33 and so on. Okay. Now for minimum frequency, you want 2m minus 1 plus or 2n 11. Okay, so that is where you will have the minimum frequency. Now you take the value of either of these two and that will give you the minimum frequency. Therefore, mu min would be equal to 3 C1 over 4L will be equal to, will realize 11 over 4L C2. So again, you can substitute the values. So 3 into 1100 over 4 into 0.5. Okay, you can calculate either of these, you will get the same value. This is 2. This will become 515 to 1650 hertz. That will be your answer. Okay, 1650 hertz is your answer. Even if you try to calculate it using this, you can also Okay, so let's try like that also. 11 into 300 over 4 into point. If again, you'll realize you will by 300 over 2, so that would have been 12 zone. Okay, so that is how you find the minimum frequency. Now, if you were asked what is the next frequency, what is the next frequency for which it would have shown the resonance, then it would be double of this. Realize for the next frequency, you need to double these values. Next frequency, you need to triple these values. So the next frequencies would have been 3300, and then you would have had 39, 4950, and so on. Okay, for which the resonance would have happened. Followed? Again, go through the answer solution and let me know if you followed it. You can also ask if there is any confusion. Okay. So I hope this one's clear. Okay. Now let's talk about beat phenomena. Hello, nothing please say, sir. There are revision on mixed type of revision and theory. Are revision on mixed type of revision and theory. Matlab, these are quick review lectures for you to quickly revise the theory and get some practice also. Yeah. All right. So now let's quickly talk about beat phenomena. So when two sound waves of the same amplitude traveling in the same direction but slightly different frequencies superimposed, then the intensity varies periodically with time, and this effect is called beats. Okay. So what happens is that if I told you the amplitude of superposition is usually in interference independent of time, but what happens when the frequencies are same? But what happens if I keep the frequencies slightly different? Then the amplitude of superposition not only changes with position, it also changes with time. At any point also it will change with time. So at any point the intensity will start varying with time. Okay. For you, physical teaching started? No, not yet, yaar. Not yet. Nothing, please. अभी कहाँ से? अभी तो I think there are no institutes that have opened yet. Only schools have been given the permission to open, right? So not yet, not yet. Please. All right. So that is what you call beat phenomena. So when you hear beats in music, so what are beats in music? So those are variation in intensities. If you have a constant sound, and if you have tan, 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 so that's what beats is actually. So in many states, offline started. Okay, I don't know. I don't think in Delhi they have allowed it. I think in Delhi they have allowed it. In Delhi there have been so many things going on in any case, so I don't think you know people have other worries. Okay. Anyhow, so let's try about calculating the beat frequency. So again, what happens is essentially that imagine you have, I already told you, you have two sound waves. Again, we will assume them to be of same amplitude traveling in the same direction but slightly different frequencies. Okay, so I will assume let the wave equations be let y1 be a sine of k1x minus omega 1t, and y2 be a sine of k2x minus omega 2. Okay, so let's assume the wave equations are like this. Okay, you are in Andhra. So in Andhra, they have started offline coachings then. Is it? Now what you will realize is therefore y resultant would be equal to y1 plus y2. Okay. So I will say a I'll take common. Then I'll have sine of k1x minus omega 1t plus sine of k2x minus omega 2t. Correct? Okay. Why nowadays less questions are asked in fluid mechanics? Okay, so they don't really have a fixed pattern as such here. Okay, nothing piece. You never know. You never know. They can suddenly start asking questions from fluid mechanics. There was a time where they hardly would ask any questions from modern physics. I remember back when I was preparing, there were hardly any questions asked from modern physics, and there used to be a huge amount of emphasis on mechanics, in fact. And then, if you see in the last, I think almost 7 8 years, they have asked a lot of questions from modern. So you never know. You never know. There is nothing fixed about it. Okay, just that how they see to balance it. Okay, all right. Again, usually depends on who's making the paper. So suppose if I was going to set the paper, okay, so it's a team of professors, no, who are setting paper, and they are only human, so they do get biased at times. Okay, so if something like, okay, if I was supposed to set up a paper, assume, so I am a mechanical engineering guy. Okay, so I would have definitely put in more questions on mechanics and fluids and thermo. Okay, and lesser questions on maybe modern and even probably, I don't know, AC and topics like those. Not even ray optics much. Okay, so that's what happens. There from alternating current, direct formula based question comes. Yes, usually in mains usually direct formula based questions only come. In advance, that is why they do not ask too many questions on AC, because uh, there is not much complication that they can create without complicating the maths of it. Okay, and since you guys are not well equipped with the maths required to solve complex problems on AC, so that is why they do not ask too many questions from AC in your advance. If you see, okay. In mains, again, they will ask you straightforward formula based questions. All right. So here now I will apply the formula of sine A plus B equals to sine A plus B by 2 into sine B minus. So this becomes A times sine of A1x plus A2x by 2 minus omega 1 plus omega 2 by 2 to cos of K1x minus K2x by 2 minus omega 1 minus omega 2 by 2. Okay, so this is the kind of equation that you should have gotten. Now, this is not the equation that you usually see. Why is that? Why is that? Okay, now you usually know that for beat phenomena to be observable, this is not the equation that you see anywhere in beats, right? Not in any of your books. In any of your books, what you realize is that they show you something different which doesn't make much sense. I don't know. Fluid mechanics is average for me, but I wanted to be mechanical engineer. Okay, so there is time. Don't worry, don't worry. You will study that. Well, have your chance. Don't worry about it. So now you know. So this term is essentially telling you the time variation of the beat phenomena. Okay. Now you don't want the beat to be very too fast, otherwise your human ears cannot detect it. Okay. What happens is for beat phenomena to be observable, for beat phenomena to be observable, omega 1 should be close to omega 2, or rather I can say nu 1 should be close to nu 2. That is the frequency, that is the basic premise of beat phenomena to be observable. I'll tell you why that is, because this nu 1 minus nu 2 is the beat frequency, and your human ears cannot detect more than 10 beats per second, more than 10 variations per second. You will in fact hear a constant sound. Okay, so you want the difference between nu 1 and nu 2 should be less than 10, usually, otherwise you won't be able to hear this. So therefore, what you realize is omega 1 would be almost equal to omega 2. Okay. Now, because you know that omega is nothing but 2 pi into nu 1 and 2 pi into nu 2. Okay. Now, if that is the case, now you have something which you know also, omega by k equals c. Now, c being the speed of sound. Now, speed of sound is usually fixed, and from here you will realize k would become omega by c. Now, in your air, where we are talking about most of our sound waves, so you realize if omega 1 is close to omega 2, your k1 is almost equal to, can be considered equal to k2, right? Or k1 minus k2 tends to 0. Okay, because your omega 1 minus omega 2 was supposed to be less than 10. And then speed of sound usually in air is of the order of 300 meter per second. So you realize from here k1 minus k2 is almost considered to be 0, or hence k1 is roughly equal to k2 is equal to k. So I can consider the two k's to be equal. Okay, and that is what you see in your equations in your books. So therefore, y resultant is often written as 2a cos of omega 1 minus omega 2 by 2t into sine of kx minus omega 1 plus omega 2 by 2t. Okay, this is the equation that you would have seen most often. Okay, now I don't know if you ever wondered, if the omegas are different, the case should have been different, right? It cannot happen that the frequency is different but the wavelength is same, because the two waves are traveling in air, so they have to have the same speed. But in your equations and books, they write it like this, you know. So they treat the k's to be same. They never treat k1 and k2. They never take k1 and k2. They simply take this as k. Kx minus omega 1t and kx minus omega 2t, which is wrong. Okay. If your omegas are different, then your case should be different, because both the waves are traveling in air. So the speed c is same. So omega by k and omega by k have to be different, no? If omegas are different, k's have to be different. Now, because of this, because k's are almost equal, so that is why we usually take that approximation. So that is an approximation which you don't mention very clearly, and that can be confusing to students a lot of times. So you can write the sine terms as almost kx by 2, and here this term disappears. Now, because of this, this is the term that represents the wave equation. Okay, traveling wave, traveling wave form I can see here. And how about this term? This term is representing the amplitude. This entire term will represent the amplitude. So as a result of these two, the superimposition of these two waves, what I have is I have a traveling wave which is traveling with a frequency of omega 1 plus omega 2 by 2, which is the average of the two superimposing frequencies, and has a time period which varies with time. and the time period varies with time with the frequency of omega 1 minus omega 2 by 2. So from here you realize is that if you draw the graph of the amplitude, the graph of amplitude varies like this. This is the graph of amplitude. Now you realize in one cycle, this is one complete cycle, right? This is your one complete cycle. In one cycle, you see two times the amplitude to be varying. This is the amplitude at a point, at a fixed point. So the x is fixed. The amplitude at any point now with time is varying. In fact, you realize the amplitude of the entire equation of the entire wave is varying. So the entire wave has an amplitude right now. The entire amplitude of the entire wave goes from 2a to 0 to 2a to 0 to 2a. Okay. So your wave is traveling, but the wave's amplitude constantly keeps on changing. So that is why you hear variations of frequencies. So wherever you are standing, the wave is passing. So sometimes the amplitude is zero, so you don't hear anything. Then suddenly it increases and it decreases and it increases and decreases, and that is what you hear. The variation in frequency. That is what beats is. Now you realize in one cycle, your frequency goes from zero to maximum twice. So once here, then once here. So you say in one cycle you hear two beats. So that's why beat frequency is twice this frequency. Okay, so please note that is a very, very important result. Beat frequency is essentially the frequency of variation of intensity. Beat frequency is 1 minus mu 2 and not mu 1 minus mu 2 by 2. That is the frequency of a variation of amplitude. But intensity depends on a square. Okay, so a square variation frequency, of course, would be double the frequency of variation of amplitude. Okay. I hope that made sense to all what I said. So you realize from here, from this amplitude, the frequency of amplitude variation is definitely, you are right. The frequency of amplitude variation is omega is mu 1 minus mu 2 by 2. But when we talk about beat frequency, we're talking about the variation frequency of variation of intensity. Intensity varies as a square. So you know if cos function has a frequency of nu, cos square function has double that frequency, right? In one cycle of cos square varies twice, repeats itself twice, right? So amplitude variation frequency absolutely is mu1 minus mu2 by 2, but the beat frequency is mu1 minus mu2. Okay. Again, a lot of students remain confused about that also. So finally, let's talk about a few questions then. So here is a question for you. So why don't you try this? You've been told a tuning fork having n equals 300 hertz uses 5 beats with another tuning fork. If impurity or wax is added on the arm of the known tuning fork, the number of beats decreases. So calculate the frequency of the unknown tuning fork. Now here I would like to bring to your attention that the questions from beats directly are usually very simple. So what happens is that mostly when IIT has asked, whenever IIT JEE, that is advanced, has asked questions on beats, they've usually mixed it up with questions from Doppler's effect. Okay, so you will hardly see any questions directly from beats because direct questions from beats are super easy. You will probably see them in mains. Okay. Now please note here, let me also bring to your attention that what happens when you load a wax on a tuning fork and when you file a tuning fork. So essentially what a tuning fork is that if you think about this, it will be obvious to you. Essentially what a tuning fork is metal thing which can vibrate. Okay, so it has one free end. So this is the free end and this is the fixed end. So it is a piece of metal which can produce standing waves. Yeah. So usually it vibrates in its fundamental frequency. Whenever you hit it and let it vibrate, it is vibrating in its fundamental frequency. And fundamental frequency, is C by 4L for such a configuration, and C is P over mu. So you will realize that mu for the tuning fork is C by 4L, where L would be this length, okay, and C is a root of P over mu. What happens is if therefore if wax is added to a tuning fork, what are you essentially doing? We are increasing mu. Mu increases. Now, if mu increases, therefore C decreases, and therefore mu decreases. So that is why when you load a tuning fork with wax, then you see its frequency decreases. Similarly, when you file a tuning fork, also if we file a tuning fork, mu decreases. Filing is you're making it thinner and thinner, and therefore C increases, and therefore your mu increases. So those are the effects of filing and wax loading tuning forks. Okay, when you file a tuning fork, its frequency increases. When you wax load a tuning fork, its frequency generally decreases. Okay. Now, based on that information, try and answer this one. Okay. So try and answer this. So now you've been told that a tuning fork of frequency 300 hertz produces 5 beats with another tuning fork. If impurity is added to the arm of the known tuning fork, the number of beats decreases. Okay. Calculate the frequency of the unknown tuning fork. Okay. So these questions are super simple. All you need to figure out is that if you had a 300 hertz tuning fork producing 5 beats, so it can produce 5 beats with two frequencies, right? 305 hertz or 295 hertz. Great. Both frequencies, both frequencies will produce 5 beats. So the unknown tuning fork either has to have a frequency of 305 or has to have a frequency of 295. Now, how do I narrow down which one of these is the case? Now I look at the next piece of information. The next piece of information says the number of beats decreases when wax is added. So when wax is added, the frequency mu dash should have been less than 300 hertz. So with 305, the beats would have increased. And with 295, the beats would have decreased. So obviously the answer is 295. Therefore, frequency of the unknown tuning fork is 295 hertz. Okay, that is something you need to remember. ठीक है भाई. This is how you judge how you judge the which one out of the two is the correct answer. Okay, you will have two pieces of information. First piece will give you two options, and the second piece of information will help you narrow down which one of those two options is the correct option. All right, so why don't we try one more problem? Let's just try one more problem, and then maybe we can wrap it up. Okay, so I have two more problems. So two more problems, and then we'll wrap it up. Okay. So here you've been told a tuning fork having frequency 158 Hz produces three beats with another. As we file the arm of the unknown, beats become seven. Then calculate the frequency of the unknown tuning fork. Okay. Okay, so try this again. This should be very simple. The information that I just told you. I think after today, we will only have one topic left for waves, which is sound waves and Doppler's effect. Okay, so in the next class, that is tomorrow, we'll try and wrap up the entire topic of waves. That would be quick review five. Yeah, so five topics I think are more than enough for a quick reviews. I have talked about most of the fundamentals. Okay, good to wrap it up. Again, this is one topic that I have intentionally taken slightly slow because a lot of people I've seen a lot of students struggle with waves a lot. Huh. Students says that waves is something that we can't handle. I've seen some of the topmost students struggle with waves. So I wanted to take my time with this topic. All right. So again, this is very simple. So 158 hertz produces three beats. So 158 will produce three beats with either 161 or with 155. Now you've been told if you file this one, if we file the arm of the unknown, so if you file the arm of the unknown, basically what is happening is that you are increasing the two frequencies. So if it was this, then the beats would have decreased. Beats would decrease if you had filed this one. If it was this one, beats would increase. And in the question, I've been told that the beats become seven. So the beats are increasing. So since the number of beats are increasing, the number of beats has increased. Therefore, the frequency of the unknown tuning fork is in fact 161. That is going to be your answer. Okay. Now let's move on to the last problem and then we can wrap up today's session. So here you've been told the string on a violin emits a note of 400 hertz at its correct tension. The string is a bit taut, okay, and produces 5 beats per second with the tuning frequency of 400 hertz. Okay, find the frequency of the note emitted by the taut string. In fact, this is the basis of tuning your guitar. So those of you who are into music and you know how you tune your musical instrument. So whenever you're tuning a guitar, you have a guitar tuner, you play a sound and then you play this frequency, and that is if you're hearing beats, then the guitar is out of tune. So when the guitar is fully tuned, you will not hear any beats. So that is the basis of tuning musical instruments also. Very interesting applications practically. Okay. All right, so this is also very simple. So I'll wait for 1 minute maybe for you guys to answer. Then we should try and wrap up this session. Yeah, so hurry up. This is a super easy question, yeah. Give me a quick answer of this. Come on. Let us have a very, very quick answer for this. It's strange, no one. All right, so let's see. So since you've been told that it is producing 5 beats with a tuning fork of frequency 400, so obviously 400 would have produced 5 beats with either 405 hertz or with 395 hertz, correct? Now, what have you been told? That the string is a bit taut. So bit taut means slightly tighter. Okay, slightly tighter. A bit slack would have meant slightly loose. Bit taut means slightly tighter. I can say since string is slightly taut, what does that imply? That implies that C is higher. If C is higher, nu would be higher. Okay. Therefore, the frequency emitted would be slightly higher than the natural frequency. It would be equal to 405 hertz. That's it. That is your answer. Okay, that is how easy it is. Yes, AP, now you are giving the answers. Yes, yes, yes. 1 and 405 are the correct answers. Well done. All right. Okay, so this is one of the last topics left, sound waves. So we will start our discussion on sound waves tomorrow. So we have run out of time for today. Let's wrap up today's discussion, and tomorrow we'll talk about sound waves and Doppler's effect. Very important. And tomorrow we'll look to wrap up our discussion on waves. Okay. Next. So this is where we will wrap up today's session. And before I leave you, let me just quickly remind you that if you're planning to get your Plus subscriptions and if you haven't gotten them, then these are the steps that you need to follow. You can go to the Plus section of your app, select your goal as IIT JEE, and click on the Get Subscription button. Okay. Now, the moment you do that, you will be redirected to the payment page where you should find a box which says, "Do you have a code?" And that is where you can enter this code RD Live. So this code will give you 10% off on all your subscription fees. So whether you go for the Plus subscription or for the Iconic subscription. And also, when you click on Proceed to Pay, you will realize that you also can get a lot of no-cost EMI options that you can choose from. Okay, and that will definitely help you reduce the burden of the payments that you have to make. You can select and spread that payment into a lot of smaller parts with no extra cost. Okay. Now, those of you who do not know what the Iconic subscription is, so let's quickly tell you about that. So the Iconic subscription is something that will take your IIT JEE preparation to the next level by allotting you personal coaches. So these personal coaches, what they do is that they will closely mentor you and monitor your performance throughout your IIT JEE journey. So you are allotted personal coaches, so you'll be getting a lot of personal attention and guidance. So students who do better under more individual attention, I think should go for this subscription. Now, apart from that personal coach and the plus benefits, you also get to attend a lot of IIT JEE workshops. You also receive expert guidelines from time to time. You get a study planner, which I know most of you could use, and you have regular test analysis sessions. So with these extra features, definitely you will power through your IIT journey. Next, students who have just entered class 11th and are wondering how to go about their studies for the next 2 years, no need to worry. You can go for one of the combo subscriptions now offered by the Unacademy. So Unacademy now offers 4 combo subscriptions which will take care of all your study needs, be it your class 11 CBSE, be it your class 12 CBSE, be it your boards, be it your IIT JEE Mains, be it your IIT JEE Advanced. So these combos offered by Unacademy are as follows. The first combo offers you the Iconic subscription for IIT JEE and plus subscription for CBSE 11th and 12th. So this combo starts at around 4,600 a month. The second combo starts offers you the Iconic subscription for all three. Iconic for IIT JEE, Iconic for CBSE 11th, Iconic for 11th CBSE 12th. And this combo starts at 5,500 a month. Then you have another combo which offers you the plus for IIT JEE and plus for 11th and 12th. This combo starts at roughly 3,000 a month. And finally, there's a combo which offers you the plus subscription for IIT JEE and Iconic for 11th and 12th. This combo starts at 3,900 a month. So you can choose a combo that suits your study needs, and then leave all your worries behind. Now, don't forget to take part in the next Unacademy Combat, which is going to happen tomorrow. You can enroll live, uh, enroll and compete live. Enroll now using the code RD Live. Okay, and compete live tomorrow. And if you do well, then you can win for yourself a lot of cool prizes also. Okay, then don't forget to take the AIM advanced exam, which is happening every Saturday, and follow the unique DPP discussions discussions happening every Monday to Thursday. Now, if you like today's discussions, then do not forget to press that like button and share it with as many people as you can so that more and more students can benefit out of this quality content being provided to you absolutely free of cost by Unacademy. So like, share, and if you're new to the channel, don't forget to subscribe and don't press the bell icon. Now, PDF of all the slides used in today's lecture will be available for download very, very soon. Next, those of you who are following us on the JEE English channel of YouTube, do not forget to connect with us on the Telegram app using this link so that you're not missing out on any of the wonderful lectures and sessions happening here on this channel of YouTube. All right, with that, I'll take your leave. But before I leave you, let me remind you of this magic referral code. So RD Live. So this code will help you the benefits of unlock the free benefits of Plus app. You can unlock the free features of Plus app with this. Then of course you will get 10% off on your subscriptions, plus an iconic subscription. And finally, of course, you can enroll in free events like the Unacademy Combat. So wherever you need a code to be entered, you can enter this and you will be through. Okay, no worries about that. So with that, let's wrap up today's session, and I'll see you tomorrow where we'll finish our discussion on ways. And till then, you guys keep practicing hard and keep studying hard and take good care of yourself. Bye bye.